You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Security Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Remediation validation is the process of confirming that a fix truly removes the identified vulnerability and does not introduce regressions. It is not enough to assume a patch or configuration change. Worked validation provides the evidence that risks were mitigated effectively and that the environment remains stable. This discipline closes the loop in vulnerability management, ensuring that issues are not only addressed but verified. Hardened organizations build validation into their workflows as a required step, recognizing that without proof, remediation is incomplete and may leave silent gaps in security. Validation must be approached through multiple lenses: functional, security, performance, and user experience. Functionally, teams confirm that the system still performs its intended tasks. From a security perspective, the vulnerability must be tested directly to ensure it no longer exists. Performance checks verify that the fix did not slow down or destabilize operations, while user experience reviews ensure no disruption for those relying on the system. Hardened organizations understand that a patch is not successful if it solves one problem but introduces others, so they validate across these dimensions holistically. Evidence collection is central to validation. Useful evidence includes updated scan results showing the vulnerability is gone, logs documenting successful patch application, test outputs confirming secure behavior, and version tags proving systems are running fixed software. Collecting this evidence makes validation defensible, showing auditors, executives, and customers that remediation was effective. Hardened environments treat evidence as mandatory, not optional, ensuring that closure decisions are supported by objective data rather than assumptions or anecdotal confirmation. Targeted retesting strategies ensure validation is precise and effective, especially for high-risk systems. Instead of rescanning entire environments, scoped scans and manual checks focus directly on the remediated vulnerability. In some cases, non-destructive exploit attempts may be conducted to confirm that the flaw is no longer exploitable. Hardened organizations recognize that high-impact fixes demand higher scrutiny, dedicating focused validation resources to ensure risks are conclusively removed without relying solely on broad, automated checks. Regression testing is a vital part of validation, ensuring that the fix did not break dependent features. For example, patching an authentication library must not cause login failures for legitimate users. Regression testing reruns critical functions across the system to confirm that normal workflows remain intact. Hardened organizations embed regression checks into validation pipelines, understanding that remediation is only successful when it strengthens security while preserving usability and reliability. Environment parity strengthens validation accuracy. Validating fixes in staging environments that mirror production ensures that results translate to real-world conditions. Without parity, teams risk approving fixes that behave differently under production loads or configurations. Hardened environments invest in staging mirrors, treating them as test beds where fixes can be validated with confidence before production deployment. This practice reduces surprises and builds assurance that validation results are meaningful. Automated validation pipelines integrated into CI/CD systems provide continuous assurance. When fixes are applied, automated tests, scans, and validation checks run automatically, reducing human effort and ensuring consistency. This integration accelerates the feedback loop and embeds security directly into delivery workflows. Hardened organizations embrace automated validation, making it part of their DevSecOps pipelines, so every update or patch receives immediate verification. Automation ensures validation scales with modern release cycles without sacrificing thoroughness. Acceptance criteria and sign-off workflows formalize when a remediation is considered validated. Criteria may include passing scans, successful regression tests, and collected evidence. Sign-offs often require both technical validation by security teams and business confirmation from system owners. This dual process ensures that fixes are not only technically effective but also aligned with organizational requirements. Hardened environments treat sign-off as a gate, preventing premature closure and ensuring accountability for every remediation. Remediation, confirmation, and final closure are distinct steps. Confirmation means the vulnerability appears resolved technically, but closure requires that all policy requirements are met, evidence collected, sign-offs documented, and baselines updated. Hardened organizations enforce this distinction, recognizing that technical success alone does not equal programmatic completion. Closure integrates governance, ensuring that fixes are not only applied but also aligned with policy, compliance, and audit requirements. When fixes are deferred, compensating controls must be validated as rigorously as patches. For example, if a firewall rule is used to block exploit traffic, teams must test whether the control actually prevents malicious attempts. Validation of compensating controls prevents false confidence, ensuring that temporary measures deliver real risk reduction. Hardened organizations document and validate these controls explicitly, treating them with the same seriousness as permanent fixes. Chaining validation steps into a repeatable checklist ensures consistency across teams. A checklist might include scanning, regression testing, evidence capture, and sign-off, applied systematically after every remediation. This prevents ad hoc practices and ensures nothing is overlooked. Hardened organizations standardize these post-remediation checklists, embedding them into workflows so validation becomes a predictable, repeatable process across all teams and assets. A concrete validation action for critical fixes involves 3 steps: run an authenticated scan, perform a focused, non-destructive exploit attempt, and capture all logs as evidence before closure. This trifecta scan results, exploit verification, and documented logs provides robust assurance that the vulnerability is resolved. Hardened organizations require this level of validation for critical issues, ensuring confidence in closure and defensibility during audits or incidents. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Manual verification by a second reviewer provides an additional safeguard for high-impact remediations. When vulnerabilities affect mission-critical systems or sensitive data, one person's validation is not enough. A second set of eyes can confirm test results, review logs, and ensure that evidence is accurate and complete. This practice prevents errors, strengthens accountability, and provides assurance to stakeholders that critical fixes have been independently validated. Hardened organizations embed peer review into their workflows, recognizing that shared responsibility reduces the risk of oversight. Timing windows for validation ensure issues are confirmed not just once but across multiple points in time. Immediate validation occurs after the fix is applied, checking for direct effectiveness. A 24-hour recheck ensures that the fix persists under real operational load. A 7-day stability check confirms that no regressions emerge over time. This layered approach catches both instant failures and delayed issues. Hardened organizations define these timing windows clearly, ensuring validation is not a one-time snapshot but a continuous assurance process. Automated alerting on regression indicators helps teams detect when fixes begin to fail. Spikes in error logs, repeated authentication failures, or unusual performance drops can all signal regressions introduced by patches. By tying monitoring systems to remediation validation, organizations receive real-time alerts if fixes degrade over time. Hardened programs configure automated alerts that highlight these signals quickly, allowing security and IT teams to respond before small regressions evolve into major outages or re-exposures. Rollback triggers tied to validation failures ensure remediation does not cause more harm than good. If tests fail, regressions appear, or user experience is significantly impacted, rollback must occur quickly and safely. Documented rollback criteria, such as thresholds for errors or performance degradation, guide teams on when to act. Hardened organizations treat rollback as part of validation, not as an emergency improvisation. This ensures that security improvements never come at the expense of system stability or user trust. Updating security baselines and infrastructure as code artifacts after validation ensures fixes persist in future deployments. If patches or configuration changes are not baked into baselines, new systems may reintroduce vulnerabilities. Hardened organizations feed validated fixes back into gold images, IAC templates, and baseline documentation. This closes the loop, ensuring remediation does not just solve today's issue but prevents recurrence tomorrow. Baseline updates transform validation from tactical assurance into strategic resilience. Evidence storage and retrieval systems make validation defensible. Collected evidence, such as scan results, screenshots, logs, and sign-off records, must be stored securely with integrity protections. Retrieval processes should be simple enough for auditors and examiners to access when required. Hardened environments establish centralized evidence repositories, ensuring proof of validation remains intact, accessible, and trustworthy long after fixes are applied. This makes remediation both provable and auditable. Communication templates standardize how validation outcomes are reported to business owners. Templates may include the vulnerability description, validation methods used, evidence collected, and confirmation of residual risk levels. Standardization ensures clarity and prevents confusion across diverse stakeholders. Hardened programs use communication templates to deliver consistent, accurate updates, building trust that security processes are thorough and transparent. Periodic sampling of closed tickets provides a quality check on validation processes. By randomly selecting past remediations and re-verifying them, organizations can assess whether validation standards are consistently applied. This practice uncovers weak points in processes and provides confidence that closure decisions remain reliable. Hardened environments use sampling as a governance control, ensuring that validation practices remain disciplined across time and teams. Validation failures should always feed into improved test cases and detection rules. If a fix passed initial checks but later failed, it signals that validation criteria were incomplete. Hardened organizations treat these failures as learning opportunities, updating test scripts, checklists, or monitoring rules to prevent repeat mistakes. Each failure strengthens the system, ensuring future validations are more comprehensive and effective. Integrating validation outcomes into patch and release planning improves future remediation cycles. By tracking which fixes validated successfully and which failed, organizations can refine patch schedules, resource allocation, and testing scope. Hardened environments build these lessons into cadence planning, making each cycle smarter and more efficient. Validation results become a key input for optimizing how remediation unfolds over time. Key performance indicators help measure the effectiveness of validation. Metrics such as the percentage of remediations validated successfully on the first attempt and average time to validate highlight efficiency and accuracy. These KPIs help leaders assess program maturity and allocate resources effectively. Hardened organizations treat validation KPIs as operational benchmarks, ensuring their programs evolve toward faster, more reliable assurance. Ultimately, validation proves that remediation worked. Closing the loop without evidence and monitoring is a dangerous shortcut. Hardened organizations enforce validation as a final, indispensable step, ensuring that every fix is effective, sustainable, and documented. Validation is not just a technical check. It is the assurance that risk has been reduced, compliance has been met, and business continuity has been preserved. Without validation, remediation remains incomplete. With it, organizations achieve true resilience. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.